All right, we're picking up with example 4 from Unit 1, Lesson 6. And in this problem, we need to solve x squared plus 13 equals 6x using the quadratic formula. So the first thing that we're going to do, they didn't show it on the screen, but we need to bring this 6x to the other side. And when we bring 6x to the left side, it's going to be negative. So I'm going to try to write that on the screen real quick. We've got x squared, now it'll be minus 6x plus 13, and now it equals 0. So if we look at this, we should see that a is 1 and b is negative 6 and c is 13. And what we're going to do is plug those numbers into the quadratic formula and simplify everything in here. When we simplify everything inside, we get the square root of negative 16, and realize that that's going to be, the square root of 16 is 4, so this would be 4i. So we have 6 plus or minus 4i over 2. And then we're going to divide 6 by 2, and we get 3, and 4 by 2, and we get 2. So our two answers are 3 plus 2i and 3 minus 2i. When you go and graph this function, let me pull it up on the calculator over here. Our function is, did it to me again, school max. X squared minus 6x plus 13. And if I go to the basic window, zoom 6, I can see this function. Notice that their window is going from negative 5 to 15 on the y on the x side and negative 5 to 15 on the y side. So if I go all the way up to 15 on my y side, I'll be able to see a little bit more of the graph like they have in their picture. Okay, so you notice that we got these two solutions of 3 plus 2i and 3 minus 2i. Anytime your solution is a complex number or it has the I in it, so it has the imaginary number inside of it, that means that the graph is not crossing the x-axis. If you look at this, you can see in either picture the graph never touches the x-axis. So earlier in this chapter, if we were asked to solve this equation, x squared minus 6x plus 13, you would have come up with the fact that there's no solutions. But now that you know that about complex numbers and imaginary numbers, you can find solutions to this equation. They're just not real solutions. They don't actually happen when they cross the x-axis. They only exist in the imaginary plane and the number 3 plus 2i and 3 minus 2i. So every quadratic equation always has two answers. It's just sometimes they're real answers and sometimes they're imaginary answers. And for this problem, they're imaginary answers. Okay, we're going to skip this page. Okay, one for you guys to check your progress on, you need to solve x squared plus 5 equals 4x using the quadratic formula. Go ahead and solve this on a sheet of paper, and when you have your answer, come back and advance to the next slide. And your answer to this problem is 2 plus or minus I. Okay, I know this is a little bit small, but this is a key concept about something called the discriminant. When we have the quadratic formula, I'm going to try to write that as quick as I possibly can. I'm definitely going to run out of space though because I can't write small enough. The quadratic formula says negative b plus or minus the square root of b squared minus 4, sorry, that's an ugly 4, AC negative b plus or minus the square root of b squared minus 4ac divided by 2a. So when you're working on this, the discriminant is actually the piece inside of the square root. It's the b squared minus 4ac. So there's a couple cases for figuring out what kind of roots, what kind of solutions you're going to have. So if b squared minus 4ac is greater than 0, there's going to be two real roots. If b squared minus 4ac is a perfect square, the real roots are going to be rational, which means you can write them as a fraction. And if it's not a perfect square, then they're going to be irrational, which means you can't write them as a fraction. If the b squared minus 4ac is equal to 0, then that means the vertex of the graph is going to touch on the x-axis, and there's going to only be one rational root, one real rational root. And if b squared minus 4ac is less than 0, then there's going to be no real roots, but there'll be two complex roots. So the next thing that we're going to be looking at is if they give us an equation, figuring out how many roots there are and what kind of roots they're going to be. So in example 5, it's part A. It says we need to find the value of the discriminant for x squared plus 3x plus 5 equals 0, and then describe the number and the type of roots for the equation. So the first thing we're going to do is find b squared minus 4ac. So we should look at this and say, okay, b is 3, a, I didn't do this in order, but you know it's all the same. A is 1, and c is 5. So b squared minus 4ac is equal to, b is 3, so 3 squared is 9. A times c is 1 times 5, and 4 times 5 is 20. 9 minus 20 obviously is negative 11. So since we got that b squared minus 4ac is less than 0, if you think back to the last slide, that means that there's going to be two complex roots. All right, let's advance to the next slide and see if they agree with us. Okay, plugging stuff in, 9 minus 20, negative 11, that's what we got. Okay, moving to the next one. Since the discriminant value is negative, it's negative 11, that means there's two complex roots, just like what we said on the first slide. Okay, part B. Find the discriminant for x squared minus 11x plus 10 equals 0, and then describe the number and type of roots for the equation. So again, what we're going to do first is we're going to write down a, b, and c. A is 1, b is negative 11, and c is 10. And when we need to plug them into the formula, b squared minus 4ac. So our b value is negative 11. When you square negative 11, that's going to be negative 11 times negative 11, which is positive 121, minus 4ac. A times c is 1 times 10, that's 10, times 4 is 40. 121 minus 40 is 81. So that tells me, since it's positive, it's greater than 0, that there's going to be two real roots. And we might need to figure out if these real roots are going to be rational or irrational. And I'm pretty sure the way you do that is we're going to look and see if this number, 81, if our answer is a perfect square or not. But let's advance to the next slide and see what they say. Okay, yeah, just so since 81 is a perfect square, it's 9 squared, there's two real roots, and those real roots are rational because this is a perfect square. If it wasn't a perfect square, there would still be two real roots, but they would be irrational, which means they can't be expressed as a fraction. Okay, here's one for you guys to practice on your own. X squared plus 18 plus 8x plus 16 equals 0. Find the number and the type of solutions for this equation. Pause the video as long as you need. When you have your answer, go ahead and come back and advance to the next slide. So our answer to this problem is A. The discriminant value is 0, which means there's only going to be one root. All right, your next one, x squared plus 2x plus 7 equals 0. Go ahead and pause it again and work on figuring out the answer to this problem. When you're ready, come back and we'll advance to the next slide. And our answer this time, the discriminant value, b squared minus 4ac, is negative 24. And anytime it's negative, it means there's going to be two complex roots. Okay, just a concept summary page. When you want to solve a quadratic equation, there's lots of different methods we've learned so far in this unit. First we learned how to graph, then we learned how to factor. We learned about taking the square root of a simple equation, like this one over here. We learned how to complete the square, and then we just learned the quadratic formula. So here's when you can use them, and here's when you should use them. Obviously, when it says these can always be used, completing the square and quadratic formula, anytime you have a quadratic function, if you're asked to find the roots, to solve it, to find the solutions, to find the x-intercepts, these methods will always give you the answers. These top three methods will only sometimes give you the answer. Sometimes you might want to use these because it'll be faster than completing the square or quadratic formula, but they only work sometimes. So you have to use your judgment on which method you're going to use to solve a problem. If the directions to a problem, if they don't specify exactly which method to use and they just leave it up to you, you're going to need to kind of be a little bit sneaky and think about which is the best method to use, because like if you use quadratic formula, for example, it'll always work, but it may not be the fastest way to get to the answer. And if you try to graph it, maybe you get the solution sometimes, but maybe sometimes you won't. Because if sometimes the solutions, if they're irrational, you won't be able to solve them by graphing. So just refer back to this slide whenever you are unsure of which method to use for solving a quadratic formula. Okay, that's the end of Unit 1, Lesson 6 on the quadratic formula and the discriminant.